Shadow maps are pixel-based, and they have advantages and disadvantages. One advantage is they're fast. They render quickly. One disadvantage is that they don't respect opacity. So if you have a transparent object, it will cast a perfectly black shadow. So if you want really realistic shadows, you want to use area shadows. If you want quick and dirty, fast renderings, and just a little bit of blur on there is good enough, then use shadow maps. Let's look at the parameters for shadow maps so we can use them to their best advantage. I'm going to select that light. Once I've got the light loaded here in the Modify panel, I'm just going to pin the stack. Click that button, and that way we won't lose these parameters even if we deselect. So we can always get back to these. Let's try shadow maps. Turn on shadow map. And in the perspective view, you can see that it looks kind of grainy. But if you do a proper rendering, you will see something different. So let's select that perspective view and click on Render Production. And you see here in the actual rendering, it looks kind of blocky and not grainy at all. Let's lock this view so that from now on, we will only render this viewport. So click the little lock icon there. So that's a shadow map with default parameters. And you can actually see the individual pixels. The reason those pixels are showing up so large is because the shadow map is spread across the entire area of the light's fall-off cone. If I select that light once again, the image of the shadow is being spread across this entire angle here. If we increase the quality, or if we make that fall-off radius tighter, we will improve the shadows. All right, so by way of illustration, I'll reopen my rendered frame window and clone this off to a separate window so we can compare them. Now I've got a copy here. This is with the light unadjusted. Then I'll select that light and go over to the Modify panel and play with the spotlight parameters. I'll bring the fall off in, so it's at 70 degrees now. I'll bring it into something like 30 degrees or even 20 degrees. All right, so we still see a shadow here. We're still in that zone. And I've got my render view minimized here, and I'll render again. And the only difference between these two renderings is the size of that fall-off cone. So this one had an angle of about 20 degrees, and this one had an angle of about 70 degrees. And you can see there's a major quality difference there. Anything that you do that will change the size of that fall-off angle is going to affect the shadows. For example, let's say I grab the Move tool, and I switch over to Local mode, and I just move the light backward. That's going to spread the shadow over a larger area, and once again, that's going to degrade the quality of the shadows. And do another rendering, render production. Here it is with the light moved away, and it looks even worse now. So the distance actually matters. All right, I'm going to undo that, bring it back where it was, set the fall off back to 70. And now let's look at the actual parameters. So that we can see the effect a little bit better in the viewport here, I'm going to change the viewport configuration. Click on the plus sign and go to Configure Viewports. And in the Visual Style and Appearance tab, you have Lighting and Shadows Quality. I'm going to bring that all the way down to the minimum of point lights and hard shadows. Click OK. And now we're seeing a very blocky approximation. And that's good. That's giving me an idea of what the shadow map is going to look like. Back in the Modify panel, I'm going to scroll down and open up Shadow Map Parameters. And there are 3 parameters here. Bias is the distance of the shadow from the shadow casting surface. Size is the resolution, and sample range is the blur. Let's try playing with the size now. So I'll do another test render. Here it is with default parameters. Once again, I'm going to clone that off to its own separate window. And then increase the size. Let's set the size to 1024. It's a good idea to use powers of 2 because that's going to optimize memory usage. So always double that, 512, 1024, 2048, and so on. Let's render that. So on the left, we have a size of 1024, and on the right, a size of 512. And you can especially see it here. This is much softer. Okay? Let's try also playing with the blur, which is the sample range. I'll bring the size way down. Let's set it to a crazy value like 128. And then reduce the sample range down to its minimum, which is 0.01, and click render. And now these are individual pixels blown up to huge size. All right, well, we'd never really use that value, but I'm just trying to illustrate. So to optimize this, to get a good look, I might do something like this. Set the size to 1024, but set the sample range up from where it was. It was set to a value of 4. Let's try that with a value of 4. But I could crank it up a bit more and soften this up. So let's try a value of 8. And now we're getting soft shadows everywhere. You may notice, however, that the shadows are not actually contacting the shadow casting object. And that's when we would want to play with the bias here. We can move the shadow towards or away from the shadow casting object. Lower values will move it in tighter or closer. We could set this to a low value like 0.1 and then render. And that's moved it in closer. And now they're actually in the right place. All right, cool. So that's one look we could achieve. Maybe we could make them a little crisper. Let's try a size of 4096. That's about the maximum you'd really ever want to take it up to. Anything beyond that, and the memory usage is going to be so much that you may as well just use area shadows or ray trace shadows. All right, with a size of 4K, I'll set the sample range back down to the default of 4 and see what that looks like. And that's not so bad. It's looking a little bit ragged there, so maybe I'll give it a sample range of 6. From a distance, that will look fine. So we can dolly back out again and render that. Pretty cool. So that's basically how shadow maps work, and that's how you can optimize their performance.